Hello, everybody. My name is Tucker, and I'm a viticulturist with Fruition Sciences. Today, I'm going to talk to you a little bit about how we calculate the WDI off of the sap flow data. This first interface here is showing us the reports that's from the sap flow and the weather station. If we look at these daily curves, we see that they're represented in hour, and the green line is data coming from the weather station, and the red line is data coming from the sap flow. The data coming from the weather station is calculated out as evaporative demand, and this can also be thought of as ET-ref. The red line below is flow, calculated off of the sap flow, and what we do is we convert it to millimeters per hour per unit ground area, just like evaporative demand is measured. We do this because we know by the vine spacing and row spacing how much land area is allocated to each vine. As we look at these curves, we then uncover the daily amount of water transpired, and we then pull up our seasonal view, and we see that each data point here is represented in millimeters per day instead of per hour. So it is the amount of water that's evaporated that day. From there, we are then looking at the relationship between these two lines to calculate the transpiration ratio, because we want to see how well is the plant responding to the demand. We see this growth period, and this is due to the leaves unfolding, and then we hit our maximum transpiration ratio. So this can be thought of as the ratio between these two lines up here. And when we hit this maximum transpiration ratio, this can be thought of as the crop coefficient. And because it is the amount of leaf area that's transpiring per that unit ground area. As we have the decline, we know we're using water, and we know that it's using water because the canopy is not getting smaller, and we know it's not due to variations in weather because it is part of the calculation. From once we hit this crop coefficient plateau, WDI is then calculated, which is this line here. And this makes it really easy because you know when this hits 40%, you know that you're transpiring at 40% of your crop coefficient, and an irrigation needs to be triggered. This is a very simple index, and it standardizes everything across different blocks with different crop coefficients, and it's very, very simple to read. If you have questions about reading it, you can check out the link to our other video for interpreting the WDI index. And if you have any questions, always feel free to reach out to me, and have a wonderful day. Thank you so much.